Thank you for joining this lesson. Remember to subscribe to our channel and to also share the link with your friends. We are told to find the area bounded by the curve y equals to x squared minus 2x minus 3, the x-axis, and the lines x equals to 2 and x equals to 4. So majority of the students, when they will find this question, they will directly go to the integration of this function with limits 2 to 4. What I mean is that they will just integrate from 2 to 4, then integrate the function 2x minus 3. This is with respect to x. Let us see the answer which will be found following this approach. So we're going to have the integration of this function, whereby it will become x power 3, and now the 3 divides here, then minus 2x, this becomes squared, and the 2 divides here such that 2 cancels now, so we remain with x squared, minus 3, we introduce x, and a constant of integration, then this is going to happen between 2 and 4. Therefore, now we substitute 4 and we subtract when we substitute 2. So we shall have 4 cubed divided by 3 minus 4 squared minus 3 into 4 plus c. Then now whatever we find here, we subtract when we substitute 2, such that we have 2 power 3 out of 3 minus 2 squared, then minus 3 into 2 plus a constant here. So let us get these values. When we have 4 power 3, this gives us 64 out of 3 minus, this one is squared, so it becomes 16. This becomes 12 plus c, then minus, this becomes 8 over 3 minus 4 minus 6 plus c. So the constants of integration will definitely cancel out, and we shall have 64 out of 3 minus 16 minus 12. This gives me negative 6 and 2/3. Then now I will subtract. When I take 8 out of 3 and I subtract 4, then I subtract 6, I'm getting negative 7 and a third. Negative 7 and a third. So what we should know is that this negative will cancel with this one, and we will be adding the 2 areas. So we shall have negative 6 and 2/3, which is a negative 20 over 3. Then we subtract, just a minute. So we shall have negative 20 over 3. Then we subtract the answer we had here, and I'm getting 2 out of 3 square units. 2 out of 3 square units. So this is what majority of the average students will do. But now, is this the exact area? Let us look at a different approach. Now my solution to this question now. So you realize it is important to first sketch our curve here. Curve x squared minus 2x minus 3. Important things when sketching curves is the x-intercept, the y-intercepts, and the turning point. Therefore, if the function is y equals to x squared minus 2x minus 3, we can get the x-intercept or intercepts, whereby we say at x-intercepts y equals to 0. So we equate this function to 0 now, because where we have y, we should have 0. And we'll get 2 values of x, such that x is either negative 1 or x is positive 3. So these are the two intercepts of x. Then now, the two of them now. Then that at y-intercept, we should know that x equals to 0. Therefore, at y-intercept, x equals to 0. So y is going to become, when we fix 0 wherever we have x, we just remain with negative 3. So the y-intercept is negative 3, and x-intercepts are negative 1 and 3. Then finally, we have an important point, which is the turning point. So at the turning point, gradient function, which is dy dx, has to be 0. So the gradient function will become, when we differentiate now this function, such that we drop 2 here, so that we have 2x, then minus 2, because the power here is just 1. So this remains 2, and x power 0 remains 1. So this is the gradient function. We equate it to 0 to know the turning point, and we say at the turning point, x is going to be 1. So if at the turning point x equals to 1, then we can find what y will be by saying at x equals to 1, y shall be, we fix 1 here. So 1 squared minus 2 times 1 minus 3. This is 1 minus 2 minus 3, and we shall get negative 4. So the turning point is 1, negative 4. Let us see the appearance of this curve. Just a rough sketching of the curve. Just a rough sketch, whereby I'm seeing with 0 here, 1, 2, 3, 4, 5. Then we have negative 1, negative 2. Then negative 3, negative 4. X-intercepts are negative 1 and 3. So the curve will cut the x-axis here and also at this point. And again, it will turn at 1, negative 4. So 1, this is negative 1, negative 2, negative 3, negative 4. Then this is going to be 1, 2, 3. So at 1, negative 4, this will be the turning point of the curve. Then it will cut the y-axis at negative 3, according to what we've calculated. So the curve is going to appear this way. This is how the curve shall appear. That is how the curve is going to appear. So now we were to integrate between 2 and 4. And now we can see the x-axis and the points 2 and 4 are bounding two different areas. There is an area here between 2 and 3. Then after 3, the area now between 3 and 4 is above the curve. So we have two different areas. One area is below the curve, below the x-axis, and another area is above the x-axis. This is an indication that this region bounded by the specified points of x and the curve are going to be calculated differently. So we have two different areas here. It is not just from 2 to 4. It is not just from 2 to 4. Therefore, we should know that we will not just integrate definitely between 2 and 4, but instead we should integrate first 2 to 3, then 3 to 4. Therefore, when we integrate the curve, remember we have the integrated function, which is already here, x power 3 out of 3 minus x squared minus 3x plus c. This one is the integrated function. Now we are going to start from negative 2 to 3. Negative 2 to 3. Then we add, when we integrate again the same function, but now from 3 to 4. From 3 to 4. Therefore, according to what we had done initially here, we know when we substitute 3. Okay, this one has not been yet done when we substitute 3 because we had substituted 2 and 4. So when we substitute 3, what shall we get? We shall have 3 cubed out of 3 minus 3 squared minus 3 into 3 plus a constant. Then we subtract when we substitute 2. And when we substitute 2, we already have the figure. When we substitute 2, the figure is -7 and a third. So we subtract -7 and a third. This one is already found. So now let's see the area we will get within this one. So we will have 27 over 3. 27 over 3 minus 9 minus 9 again. This is going to give us -9. Then minus 7 and a third, which is also negative. It becomes a plus. So we shall add now positive. So we say 7 and a third, which is a 21 plus 1, 22 out of 3. So we will have this one plus 22 out of 3. And this gives us -1 and 2/3 square units. Okay, -1 and 2/3, which means that the area below the curve between 2 and 3 is going to be 1 and 2 out of 3 square units. What about now between 3 and 4 for the same curve between 3 and 4? So when we substitute 3, we have gotten -9. Then we subtract. When we substituted 3, because we're integrating now between 3 and 4. So when we substituted 4, we got -6 and 2/3. -6 and 2/3. -6. Sorry for this. We should start with the value after substituting 4, which is the one being -6 and 2/3. Then we subtract the value when we substitute 3, which is after substituting 3, we are getting -9. So we have -6 and 2/3 minus -9. So -6 and 2/3 we shall add, because of the two negatives, a 9. So this shall be 9 minus 6 and 2/3. This becomes 18 plus 2, 20 over 3. And this is 2 and a third. So we have 2 and a third square units above the curve and 1 and 2/3 square units under the curve. So when we add the two now to get out our area, we'll have 1 and 2/3 plus 2 and a third. This will give us exactly 4 square units.